Alright, so given a coin with unknown probability of landing heads, we can flip this coin a certain number of times, which is our sample size for a number of trials. So the more times you conduct this experiment, the more likely you are to get more accurate results. So in my example, I did 1,000 trials. And then the formula for determining the needed sample size is the z-score squared times the estimated probability times 1 minus the estimated probability. And you can divide all that by the margin of error squared. So for a 95% confidence level, you use a z-score of 1.96, and then for the estimated probability of heads, we use 0.5, which is the worst case scenario. And then for the margin of error, we can use 0.05, which is stating it's within 5% of true probability. And then, so I did a random number, and then I did that formula for the sample size here. And then I conduct the experiment 1,000 times, and here's the function that I use to conduct the experiment. So since my sample size was 384, that was the calculated amount. This function conducts the experiment 384 times, and then I did that 1,000 times for each trial. I mean, for the total number of trials I wanted to do. And then, so the results look very closely to what the actual probability. So the actual probability was 78.8% chance of landing heads, and the sample mean of all the experiments that we were done was 78.7%. So it was actually very close to the actual probability. So you can see it follows a normal distribution. The results, we had more of the results closer to the actual probability, and then as you get further away, it's less likely to get results that are more standard deviations away from the actual probability.